What most people call silicone plastic isn't actually plastic. It can be as soft as rubber, as flexible as a gel, and withstand temperatures that would melt many types of plastic. But it's not rubber either, at least not in the way most people think. So, what exactly is silicone? Even more surprising, it all begins with one of the most common materials on Earth, sand. Yet, just a few decades after it was invented, this material was being used to solve one of the most dangerous problems faced by military aircraft during World War II. In this video, we'll explore the fascinating journey of how ordinary grains of sand are transformed into silicone. Today, silicone is found in almost every industry, from household products, electronics, and construction to medical devices and aerospace. But this remarkable material is only a little over a century old. In the early 1900s, British chemist Frederick Stanley Kipping began studying silicon-based compounds in the hope of creating an entirely new type of material. He was also the person who coined the name silicone for this group of compounds. However, for many decades, his research attracted little attention because no one had yet found a practical way to manufacture silicone on an industrial scale. Everything changed in the early 1940s, when scientists successfully developed a process for large-scale silicone production. From that point on, a material that had once existed only in laboratories quickly became the foundation of countless modern technologies and continues to find new applications around the world today. A single letter makes all the difference between two materials that have changed the world. Yet even today, many people still confuse silicon and silicone. Silicon, without the E, is a chemical element with the symbol Si. It is a gray, metallic-looking solid, and the second most abundant element in Earth's crust, making up about 28% of its mass, behind only oxygen. Because its electrical conductivity can be precisely controlled, silicon became the foundation of the semiconductor industry and is the key material used in almost every modern computer chip. That's also why America's famous technology hub is called Silicon Valley. Silicone, with an E, is something completely different. It is not an element, but a synthetic material made from silicon through a series of chemical reactions. Unlike silicon, silicone does not occur naturally anywhere on Earth. Thanks to its unique molecular structure, it can be as soft as rubber, as flexible as a gel, or as smooth as an oil, while remaining stable under conditions that would cause many ordinary plastics to soften or melt. Although their names differ by only one letter, silicon and silicone have completely different structures, properties, and applications. The story begins in a place few people would expect: ordinary sand. The sand children use to build sandcastles is actually rich in quartz, also known as silicon dioxide, SiO2. In this compound, silicon atoms are tightly bonded to oxygen atoms, which means silicon cannot be separated simply by melting the sand. To extract the silicon, quartz sand is mixed with carbon and fed into an electric arc furnace. Inside the furnace, an extremely powerful electric current generates temperatures of about 3,270 degrees, hotter than the lava from many volcanoes. At this temperature, the carbon reacts with the oxygen in silicon dioxide, pulling the oxygen atoms away and forming carbon monoxide gas. What remains is silicon, with a purity of about 99%. The silicon is then cooled and crushed into a fine gray powder with a texture similar to flour. But don't let its appearance fool you. This powder is still only the starting material, not silicone. Just as flour is not yet a loaf of bread, silicon must go through a series of specialized chemical reactions before it becomes the flexible, durable material used in everyday life. The gray silicon powder is only the starting material. To turn it into silicone, manufacturers use a process known as the direct process. This is the most important step in the entire production chain, and the key reason silicone can be manufactured on an industrial scale. First, the silicon powder is heated to about 572 degrees Fahrenheit. Methyl chloride gas is then passed over the hot silicon, while a small amount of copper is added as a catalyst. The copper does not become part of the final product, but it helps the silicon react much more efficiently with the carbon-containing methyl groups. The reaction produces a mixture of different chlorosilanes, with the most important being dimethyldichlorosilane. This compound is the essential intermediate used to produce silicone. The process was developed independently by two scientists in the 1940s, Richard Müller in Germany and Eugene Rochow in the United States. Today, it is commonly known as the Müller-Rochow process. At this stage, the reaction has produced only a mixture of different molecules. To obtain the desired compound, the mixture is sent through a fractional distillation system. Because each compound has a different boiling point, they can be separated one by one through precise temperature control. Once dimethyldichlorosilane has been isolated, it reacts with water. During this hydrolysis reaction, the chlorine atoms are removed from the molecule, forming hydrochloric acid as a byproduct. The remaining molecular units then begin linking together to form long chains called polydimethylsiloxane, or PDMS. PDMS is the base material used in most silicone products. However, PDMS is still not a finished product. Depending on the length of its molecular chains and how those chains are linked together, the same base material can become a silicone oil, a soft gel, or a durable silicone rubber. Because it can be made into an oil, a gel, or a rubber, silicone is used in an enormous variety of products. In its liquid form, silicone oil is commonly found in cosmetics, shampoos, and lubricants. As a gel, it is used in shock-absorbing pads and certain medical devices. When made into silicone rubber, it becomes baking molds, kitchen utensils, baby bottle nipples, sealing gaskets, construction sealants, and even phone cases. Its excellent heat resistance, water resistance, and long-lasting flexibility also make silicone an essential material in the construction, electronics, automotive, and aerospace industries. Have you ever wondered why a material used in baking molds, baby bottle nipples, and even medical devices can safely come into direct contact with the human body? The answer is that high-quality silicone, especially food-grade and medical-grade silicone, is highly chemically stable. It reacts very little with food, water, or most common chemicals. That's why it is widely used in products where safety is essential. However, not all silicone products meet the same standards. Low-quality silicone or silicone containing impurities may not be suitable for contact with food or exposure to high temperatures. For this reason, silicone intended for kitchenware and medical applications must pass strict safety and quality tests before it can be sold. Silicone's biggest breakthrough came in the early 1940s, just as large-scale manufacturing became possible and World War II was underway. In 1943, Dow Corning was founded to produce silicone on a commercial scale. One of the company's first products was a silicone compound used to coat the ignition wiring harnesses of Allied military aircraft. At high altitudes, the thin air makes electrical arcing more likely, which can damage ignition systems and affect engine performance. The silicone coating provided electrical insulation, resisted moisture, and helped prevent this problem, allowing aircraft to operate more reliably under harsh conditions. What had once been a little-known laboratory material quickly became an important part of military aviation. Despite its many advantages, silicone is not a perfect material. Compared with many common plastics, it is more expensive to produce because of its complex manufacturing process. It also has relatively low mechanical strength and does not bond easily to materials like metal or glass without specialized adhesives. Its exceptional durability also creates an environmental challenge. Silicone breaks down very slowly and is difficult to recycle, making it hard to replace in many applications. As a result, the next challenge is not improving silicone itself, but developing more sustainable ways to use and recycle it. From ordinary grains of sand, humanity has created a material that now exists in kitchens, hospitals, aircraft, and even spacecraft. Silicone is a powerful example of how science can transform one of Earth's most common materials into something with extraordinary value. It also reminds us that the true importance of an invention is often recognized only when the world needs it most. But the story of silicone is far from over. The next challenge is no longer making it stronger or more flexible. Instead, it is finding better ways to produce and recycle it, so its remarkable durability does not become a burden for the future. Do you think silicone is one of the smartest materials ever created, or is it simply a great solution that still has room for improvement? Let us know your thoughts in the comments.